Good morning, children. Today we are going to discuss a new chapter, surface areas and volumes. We have already learnt about surface areas and volumes of solid shapes in class 9. Here in class 10 we are going to discuss about the combination of solids. Here let us recollect the surface area and volume of a cuboid. For a cuboid whose dimensions are length is equal to L, breadth is equal to B and height is equal to H respectively, we can find the surface area of a cuboid. Surface area of a cuboid is equal to the sum of areas of its 6 rectangular faces. Therefore, TSA or total surface area of a cuboid is 2 into LB plus BH plus LH. Same way, lateral surface area or LSA is the area of all sides apart from the top and bottom faces. Therefore, we can say LSA of a cuboid is equal to 2 into L plus B into H. Same, volume is equal to L into B into H. Now, let us see the surface area and volume of a cube. For a cube, we know the length and breadth and height are equal. Suppose the cube is of length A, we can say the total surface area of the cube is equal to 6A square. Lateral surface area of the cube is equal to 4A square and volume of a cube is equal to A cube. Cylinder and its surface area and volume. Take a cylinder of radius r and height h. The curved surface area of a cylinder of base radius r and height h is 2 pi r h. The total surface area of the cylinder will be the curved surface area plus area of two circular bases, which is equal to 2 pi r h plus 2 pi r square, which can be written as 2 pi r into r plus h. And volume is equal to base area into height. The base area is pi r square and height is h. Therefore, volume of the cylinder will be pi r square h. Let us see the surface area and volume of a right circular cone. Consider a right circular cone with slant height L, radius r and height h. Curved surface area will be pi r L, where L, the slant height, is found using the Pythagoras property, which is equal to square root of h square plus r square. Total surface area of the cone is pi r into r plus L, and the volume of the cone is equal to 1 by 3 pi r square h. Sphere and its surface area and volume. For a sphere of radius r, the curved surface area and the total surface area remains the same, and that is equal to 4 pi r square. Volume of a sphere is equal to 4 by 3 pi r cube. Hemisphere and its surface area and volume. A hemisphere is half of a sphere. Therefore, CSA is equal to half of 4 pi r square, which is equal to 2 pi r square. Total surface area is equal to curved surface area plus area of the base circle, and the answer will be 3 pi r square. Volume is equal to 2 by 3 pi r cube. Here in this slide we are given the formulas of all the solid shapes which we have learned. LSA of a cuboid is 2 into L plus B into H. TSA is 2 into LB plus BH plus LH. Volume is equal to LBH. For a cube, LSA is 4A square, TSA is 6A square and volume is equal to A cube. For a cylinder, CSA is 2 pi RH, TSA is 2 pi R into R plus H and volume is equal to pi r squared h. For a cone, CSA is pi r L, TSA is pi r into r plus L, and volume is equal to 1/3 of volume of the cylinder, which is 1/3 pi r square h. For a sphere, CSA is equal to 4 pi r square, TSA is also 4 pi r square, and the volume is equal to 4/3 pi r cube. For a hemisphere, CSA is 2 pi r square, TSA is 3 pi r square, and the volume is half of the volume of the sphere, which is 2/3 pi r cube. Now let us learn surface area of combination of solids. Areas of complex figures can be broken down and analyzed as simpler known shapes. By finding area of these known shapes, we can find out the required area of unknown figure. Here in figure 1, we can see the total surface area of the new solid is equal to the curved surface area of first hemisphere plus curved surface area of the cylinder plus curved surface area of the second hemisphere. And in figure 2, TSA of the new solid is equal to CSA of the cylinder plus CSA of the cone and the base area of the cylinder. Based on combination of solids, let us start exercise 13.1, page number 244. Question number 1. Two cubes, each of volume 64 cm cube, are joined end to end. Find the surface area of the resulting cuboid. Here we are given two cubes and each cubes are of volume 64. So we can write volume is equal to 64 cm cube. The volume formula of a cube is a cube is equal to 64, and from that a is equal to cube root of 64, which is equal to 4 cm. When the two cubes are joined end to end, the new resulting solid is a cuboid. We can see the length of the new resulting cuboid will be 4 plus 4 is equal to 8 cm, breadth will be 4 cm, and height will also be 4 cm. The surface area of the cuboid is 2 into LB plus BH plus LH, which is equal to 2 into 8 into 4 plus 4 into 4 plus 8 into 4, which is equal to 2 into 32 plus 16 plus 32 equal to 2 times 80, and the answer is 160 centimeter square. Question number 2. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 cm and the total height of the vessel is 13 cm. Find the inner surface area of the vessel. We can see the figure, which will be the hollow hemisphere and a hollow cylinder mounted on the hollow hemisphere. When it is separated, we can see a hemisphere as well as a cylinder. We are given diameter is equal to 14. Since the diameter of the hemisphere is 14, the radius will be 7 cm. The total height of the vessel is given 13 cm. That means that is height of the hemisphere plus height of the cylinder is 30. If the radius is 7, the height of the hemisphere is also 7. From that we can find height of the cylinder equal to 13 minus 7 equal to 6 cm. Now let us find the inner CSA of the vessel. CSA of the vessel will be CSA of the hemisphere plus CSA of the cylinder. The formula will be 2 pi r square plus 2 pi r h. Here the radius of the cylinder and the hemisphere are same. Taking common, we can see it is 2 pi r into r plus h. Substituting the values, 2 into 22 by 7 into 7 into 7 plus 6, that is height of the cylinder, will be 2 into 22 into 13 equal to 572 centimeter square. Question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. Here we can see the toy is in the shape of a cone and it is mounted on a hemisphere of same radius. We are given radius of the cone is equal to 3.5 centimeter. Therefore, radius of the hemisphere also will be 3.5 centimeter. Now we are given the total height of the toy is equal to 15.5 centimeter. That is, height of the cone plus height of the hemisphere is equal to 15.5. As we know, the height of the hemisphere is same as the radius of the hemisphere. We can find the height of the cone as 15.5 minus 3.5 equal to 12 centimeter. To find the total surface area of the toy, we can see it is the curved surface area of the cone plus curved surface area of the hemisphere. The formula is 2 pi r square plus pi r l. Taking pi and r as common, we have pi r into 2r plus l. Here L is the slant height of the cone. To find the slant height of the cone, we have to apply the Pythagoras property, which is equal to square root of h square plus r square. H is equal to 12 and r is equal to 3.5. We can see it is 12 square plus 3.5 square, and which is equal to square root of 144 plus 12.25 equal to square root of 156.25, and the answer is 12.5. Substituting the values, we can see 22 by 7 into 3.5 into 2 into 3.5 plus 12.5. 7 and 3.5 get cancelled and we can write it as 22 into 0.5 into 2 into 3.5 is written as 7, 7 plus 12.5. That is, finally we have 11 into 19.5 is equal to 214.5 centimeter square.